Every time you call a language model API, it starts fresh. No memory of the previous call. No awareness of what happened in step 3. No continuity between runs on different days. An LLM is stateless by design, yet agents need to remember their plan across 50 steps and recall facts from previous sessions. The question: how do you give a stateless model persistent, actionable memory without making every call slow and expensive? The answer isn't one system, it's 4, each designed for a completely different kind of memory with different latency, capacity, and persistence. Get the wrong one and your agent forgets. Use them all and your agent thinks. Every iteration of the observe-think-act loop touches memory at every stage. When the observation arrives, the perception module checks. Is there relevant context in external storage? Retrieved documents are injected into the context window. The reasoning engine then thinks with everything it has: the observation, the retrieved facts, the conversation history. After the action, significant new facts can be written back to external storage. And KV cache preserves the expensive computed attention states from the previous call, so you don't pay to recompute the system prompt. Memory isn't a separate system you bolt on. It's woven through every step of the loop. In-context memory, working memory, is what the model actively thinks with right now. Everything in the context window is available at 0 latency. The model can reason directly about anything there. This is your most reliable memory store, but it's finite. A Claude 3, 5-sonnet context holds 200,000 tokens, roughly 150,000 words. At step 15 of a complex task, you may have accumulated 180,000 tokens of history, tool outputs, and observations. Context rot begins around 65 to 75% of the limit. Old context is silently truncated. The model doesn't warn you, it just forgets. Treat the context window like RAM, prune aggressively when it approaches 50% full. External memory, vector databases, solve the persistence problem. Documents and facts are stored as embedding vectors, high-dimensional numerical representations of meaning. When the agent needs information, it sends a query. The database returns the most semantically similar stored entries. Qdrant answers in 4 milliseconds for 1,000,000 stored vectors. Pinecone in 16. These numbers are fast, but here's what engineers learn the hard way. Retrieval speed is not your bottleneck. Retrieval quality is. A 4-millisecond query that returns the wrong document is worse than a 50-millisecond query that returns the right one. Build an evaluation set for your retrieval layer. Test it before you trust it. 2 more memory layers. In weights, memory is expertise baked into the model during training, permanent, 0 latency, but expensive to update. Fine-tune when you need to change how the model behaves. Use external storage for facts that change. The 4th layer, KV cache. During a long call, the model computes attention scores for every token in context. KV cache stores those computed values, so they don't need to be recomputed on the next call. For agents that reuse the same long system prompt, this reduces costs by 60 to 80%. Research shows persistent KV caching yields an 11 to 136 times speedup on long context agents. Memory systems fail in 3 specific ways. Context overflow is silent. Old tokens are truncated without warning. Your agent forgets its goal. Stale retrieval is confident. The vector database returns an outdated document. The agent builds on facts that are no longer true. Catastrophic forgetting is permanent. Fine-tuning on new knowledge can overwrite previous capabilities. The model loses skills it once had. Memory failures compound. A wrong retrieval at step 3 creates bad context at step 4, which produces a wrong tool call at step 5. The repair is instrumentation. Log what goes into memory, what comes out, and when it was last updated. Every time you see information an agent needs, route it to the right memory layer. Is it needed right now? In context. Was it learned once and never changes? In weights. Does it change and need to persist across sessions? External vector database. Is it expensive to compute and reused constantly? KV cache. The detective metaphor holds. The notepad in the pocket is in context memory. The case file cabinet is external storage. Decades of investigative expertise is in weights. The photographic memory of the key crime scene is KV cache. Every layer has a job. Get the routing wrong and your agent either forgets everything or pays to recompute everything. Pause here.